In this video, I will show you how to write the standard form equation of various conic sections. I'm talking about parabolas, ellipses, hyperbolas, and circles, given various types of information. For problem number 5, we're told that we're dealing with a parabola and we're given the focus and the directrix. We need to write an equation for this. Let's start by graphing what we have. We have a focus at -3, 2. Okay, so let's just sketch a rough graph of that. Okay, so -3, 2 would be right here. So here's the focus. Okay, now the directrix is at x equals 1. X equals a number is a vertical line. So we're talking about a vertical line at 1. So this is my directrix. All right, so I have the focus and the directrix. The vertex should be halfway between these two. All right, the vertex should be right in the middle between the focus and the directrix. These are 4 apart, so the vertex should be right here. And I know that I'm dealing with a parabola that it's facing to the left, because the parabola is always sort of wrapped around the focus. Notice that the vertex is the point -1, 2. So I can begin to write the equation now, because when I'm dealing with a sideways parabola, I always know that the standard form will be y minus k squared is equal to 4p times x minus h not squared. If it's sideways, the y part is first. All right, if it was opening up or down, the x minus h would be here instead. Because I know the vertex, that's my h and my k, then I know that this y minus k is really going to be y minus 2 squared is equal to 4p times, and then because of the -1, I'll have x plus 1. Okay, this is problem number 5, just in case someone's fast forwarding through this. Okay, so I'm almost done. I just need the p-value. Well, understand that the p-value is going to be the distance from the vertex to the focus. So this arrow that I'm drawing right now represents the p-value. So my p-value is going to be -2. Negative because it's going to the left. If it were going to the right or up, it would be positive. If it's going left or down, it would be negative. So the p is -2. So if I put a -2 in right here, then that's going to make this -8. Okay, so that's why my final answer is going to be y minus 2 squared is equal to -8 times x plus 1 not squared. And that's it. This is the equation for number 5. For number 6, we have an ellipse with a major axis length 24, and we're given the focus. Well, we're given both of the foci. So, first of all, I need you to understand what the major axis is. So if I have an ellipse, so let's say it's doing something like this, the major axis is going to be the distance from one vertex to the other vertex. In other words, it's going to be the length of the ellipse, the long way. So this is going to be 24. So that means the distance from the center to a vertex is going to be 12. Okay, so this distance is going to be 12. And that's going to be my a value. All right, that's going to show up in the equation later. So anyway, just keep that in mind. Anyway, let's graph what we have. So we have foci at 4, 3, and 4, -15. All right, so here's a focus at 4, 3, and 4, -15. These are the foci. Let's think about this for a minute. How far apart are these guys? All right, from here to here, how far apart is this? So this is up 3, this is down 15. So that's a total of 18. All right, so this blue distance is 18. Remember that the total major axis is 24. So let's think about that. What's 24 minus 18? So that's 6. All right, so that means so far we're at the foci. Okay, now I understand this one's horizontal, but our actual one is vertical. So if this distance from here to here is 18, that means we need 6 more to make a total of 24. So we're going to need an extra 3 on either end, okay, for a total of an extra 6. Okay, so back to our actual picture. So far we have 18. The total major axis is 24. So if I do an extra 3 on either end, that should be the vertices. So if I go 3 up from here, okay, that'll put me here at 4, 6. Okay, that's going to be my vertex. If I go 3 down from here, okay, that's going to be 4, negative 18. Okay, and now if I looked at the distance from vertex to vertex, that's going to be 24, like I wanted. Anyway, right now I need to think about what the center is as well. So the center point should be right in the middle between these guys. So where's that going to be? Well, like I said, this is 18 from focus to focus. So if I go 9, that should be halfway. So that's what I'm going to do. I'm going to go 9. So let's see. So down to the x-axis, I've gone 3 so far. So I need to go 6 more. So I'm going to go down to negative 6. Okay, in other words, my center point is going to be the point 4, negative 6. So now I can really begin to write the equation of this ellipse. We know that the ellipse is always going to be x minus h squared plus y minus k squared, and it's going to be equal to 1. When it's vertical like this, that means it's longer in the y direction. So my a squared will be here, because for ellipses, well, the a value is always the distance to the vertex. All right, in this case, that's vertical. And so my b squared is going to be here. So this is the model that I'm going to use for this vertical ellipse. Now that I know the center, I can go ahead and do the numerator. So this is going to be x minus 4 squared over b squared. And this is going to be y plus 6 squared. Okay, all I need is my a squared and my b squared. Well, you know that the a value is going to just be the distance from the center to the vertex. Okay, so that's my a value. And remember, so look, so this is a y value of positive 6, this is negative 6, so my a value is 12. Also, we knew that from looking at this picture. Remember, right from the beginning, since the major axis is 24, half of that would be the a value. So we knew the a value was going to be 12. So my a value is 12, which means that a squared is 144. Okay, so notice that this a value is vertical. That's the y direction. So my 144 will definitely go with the y term. So 144. So all I need now is my b, or my b squared. What's that going to be? Well, we don't know it. We're going to have to do an extra calculation. We have the a value. We also can figure out what the c value is. Okay? The c value is the distance from the center to a focus. So let's see. So my c value is going to be, right, this is from -6 to 3. So that's going to be 9. The c value is going to be 9, which means that c squared is going to be 81. But what I really need right now is b squared. But look, we know that c squared is equal to a squared minus b squared for an ellipse. So that means that 81, because that's my c squared, is equal to 144 minus b squared. Now, if I add b squared to both sides and subtract 81 from both sides, basically I'm going to move this to the left and move this to the right. Then I'm going to get b squared is equal to 144 minus 81. Okay, so what's that? So that is 63. So b squared is 63. So I can just go ahead and put that 63 in the denominator right here. And that's it. This is the standard form equation of the ellipse. All right, that was it. That was problem number 6. Number 7, we're given a general form equation, and we need to convert this to standard form. This is an ellipse, by the way. I can tell, looking at the x squared and the y squared, see how they're both positive, but yet they have different signs. I'm sorry, they're both positive, so which means they have the same sign, but they have different coefficients. I have a 6 and a 9. If these were the same, it would be a circle. Anyway, so I know it's an ellipse. I need to group together my x terms and my y terms. And that 87 needs to get out of the way. So I'm going to have 6x squared plus 24x plus 9y squared minus 90y is equal to negative 87. So before I go doing half the middle squared, I need to factor the 6 outside of parentheses. So I need to factor this out. So x squared plus 24 divided by 6 is 4. So I'll have 4x. Leave space to complete the square. I need to bring the 9 outside of parentheses. So this will be y squared minus 10y. Leave space to complete the square is equal to negative 87. Now is when I complete the square. Half the middle squared. Half of this is 2. 2 squared is 4. So I put a 4 right here. I need to balance it out on the other side. But this is really 6 times 4. So I'm going to put a 24 on the other side. Half of this is negative 5. Square it. That's positive 25. But this is really 9 times 25. And that's 225. So I'm going to have plus 225 over there. So time to factor. So what I have now is 6 times, and this will be x plus 2 times x plus 2, or x plus 2 squared. And I will have 9 times y minus 5 times y minus 5, or y minus 5 squared. And then I just need to add these 3 numbers together. I'm getting 162. Now for an ellipse, I know that I need a 1 over here. So I'm going to divide everything by 162. Okay, now in my heart of hearts, I'm hoping that 6 goes evenly into 162. So 162 divided by 6 is 27. So this is going to make x plus 2 squared over 27. All right, hopefully 9 also divides in evenly. 18. All right, 9 goes into 162 18 times. So I have y minus 5 squared over 18 is equal to 1. So that's it. This is the standard form equation of the ellipse. All right, did they ask us anything else? No, just the equation. All right, that's it. Okay, number 8 is going to be very similar. Notice that only one variable is squared, so this is a parabola. Okay, so in your mind you should be thinking, oh, so this one is going to look more like x minus h squared is equal to 4p times y minus k not squared. This is the model. I still need to group together my x terms, so I'm going to have 2x squared minus 16x. Okay, now the 8y and the negative 8 need to go to the other side of the equation. So subtracting 8y from both sides and adding 8 to both sides. All right, I have this. Now, before I complete the square, I really need to pull this 2 outside of parentheses. Or better yet, I'm noticing that all 4 of these numbers are divisible by 2. So the even smarter thing to do would be just divide everything by 2 right now. All right, you can't have a number here at the end. Sooner or later, you have to divide by that number. So I'd rather just do it now. So this is going to give me x squared minus 8x is equal to negative 4y plus 4. Okay, now I can complete the square. Half the middle squared. Half of this is negative 4. Square it, you get 16. So I need to add 16 to the other side. This will now factor as x minus 4 times x minus 4, or x minus 4 squared. So I have negative 4y plus 20. Okay, now I need to factor the 4p outside of parentheses. Okay, so in other words, I need to factor this negative 4 out. So I'm going to have x minus 4 squared equals, and I pull out the negative 4, and that's going to leave behind y minus 5. Think 20 divided by negative 4, so that's negative 5. And that's it. This is the standard form equation of the parabola. All right, this will be the last one for this video. We need to write the equation of a hyperbola with a vertical transverse axis and an asymptote equation shown here. First of all, what does that mean about the vertical transverse axis? Okay, so hyperbola, y'all, okay, so let's say this is my hyperbola that's going like this and like this. The transverse axis is a segment connecting the vertices. So this blue segment is my transverse axis. Okay, so this is a vertical transverse axis. Or if I had a horizontal transverse axis, then now I'm talking about a hyperbola that goes like this. Okay, so we're basically talking about a vertical hyperbola. So remember, when we talk about the standard form equation of a hyperbola, sometimes we have x minus h squared, okay, over a squared minus y minus k squared over b squared is equal to 1. Okay, so that's one version of this. But then sometimes we have the y minus k squared first, and then x minus h. Okay, and this is the one that we use when it's horizontal. When we have a horizontal hyperbola, a horizontal transverse axis. This is the one that we use when you have a vertical transverse axis. Okay, so if it's vertical, the y term goes first. So that's the first thing you had to understand, is that your y term should definitely be first when you write this. Okay, now, the next thing you have to understand is when we write the equation of the asymptotes, this is the y minus k, and this is the x minus h. So I can plug those into the equation right now. So my y minus k is really y plus 2. So I'm going to have y plus 2 squared should be first. Okay. Whoop, I don't know why I put an equal sign there. It's a minus sign. Okay, now the x minus h should be second. So in this case, that's x minus 6 squared. Okay. Now, all I need is my a squared and my b squared. So look. One of these is A and one of these is B. It's just a matter of which is which. Okay? In a way, it doesn't matter. What matters is that you know that the slope, this 2/3 is the slope. And you know that slope is rise over run. Okay? So this 2 is the vertical number. Okay, so you know, regardless of whether or not you knew that it was a squared or if it was just or b squared, you know that it's vertical because it's the rise. So this number is going to give you the denominator of the y value because it's vertical. But it's going to be a 4, right? Because this is a, and we want a squared. Okay, and then the 3 is the b value. All right, it doesn't matter. Like even if you got these confused and you thought this was b squared and you thought this was a squared, that doesn't matter. Either way, you know that this is the run. It's horizontal, so you know that it's going to go for the x term no matter what. But we're going to put a 9 because this is b and we want b squared. So that's it. This should be the equation of the hyperbola with a vertical transverse axis and this asymptote equation. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.